Hi everyone, in this example we're going to take a look at something called the superposition theorem. And what it basically does is takes a look at each individual source. In this case here we have two DC sources, and we basically look at each one individually and see what each one does. And then we look at those and combine them to figure out what the overall current is. In this case, we want to find the current through RL, and I want to find the voltage across the load. So that's my goal here. There's the load resistor. We want to find that current, and we want to find the voltage drop across there. So we're going to break this up into steps. The first step is to just take a look at what VS1 does and really just disregard VS2 in this case here. So step number one, what we're going to do is short VS2 and basically just look at what VS1 does in terms of supplying current to the load. So that's our first step. So let's just write this step out here. So that's what we're going to do. So if we redrew this circuit then with that in mind, then we've got VS1, and then we're going to short out VS2. We'll put in our resistors, and then like I said, we'll just look at this in terms of VS1 and what it does. So there's our resistor values, and there's our load resistor value, 15 ohms. So let's take a look at this circuit with respect to VS1, which is 21 volts. So if I want to find the current supplied by that, the first thing I need to figure out what is the total resistance that's seen by that DC source. So if I want to find the total current, then I need to find the total resistance. So yes, first step, find the total current due to VS1. So like I said, I need to find the total current, and like I said, to do that, I'm going to need to find the total resistance. Well, hopefully you can see that with respect to VS1, the total resistance it's going to see is basically 15 ohms in parallel with 60 ohms, and then it combines back together and all the current goes through that last resistor, the one that's 30 ohms. So we've got some current splitting one way, some current splitting another way, and like I said, all of that current is going to go through that 30 ohm resistor. So we're going to see the total current at that node right there represented with the arrow. So we'll write this out here as our total. Maybe we'll call this R total 1 because we're going to do this again with respect to VS2. So let's call this R total 1. So that's 15 ohms in parallel with 60 ohms. And then all of it goes through that 30 ohm resistor, so it looks like that. You guys are good enough now that you know how to do these resistors in parallel. 15 in parallel with 60 turns out to be 12 ohms. And then we'll add that to the 30 ohm resistor, and we get a total resistance of 42 ohms. So next thing, let's find the total current. And again, we could call that total current 1 if we wish, because we're going to do this again for VS2. So the total voltage supplied by VS1 is 21 volts. We're going to put that over 42 ohms, and we get 0.5 amps. Now, what we want to do is find how much of that is going through the 15 ohm resistor, not all of it. So we got to be very careful here. Not all of 0.5 amps goes through that 15 ohm resistor. We're going to have to use the current divider formula. And we're going to have to be careful here with the total resistance because we're talking about the total resistance in the parallel portion. So watch out, be careful with this. So in the parallel portion, the total resistance is 12 ohms. So we'll write that here in a second. So that's RP, let's say 1, that's the parallel total. And we want to figure out how much is going through that 15 ohm resistor. So we're using the current divider formula. So that's 0.5 amps. And that total parallel resistance is 12 ohms. And that goes over 15 ohms. Figure that out. And that comes to 0.4 amps. So 0.4 amps goes through that 15 ohm resistor due to VS1. So be careful with the current divider formula in this case here. So that means 0.1 amps ends up going through the other branch. And if we add those together, just to show you the basic math here, we can see that those do sum together to give you 0.5 amps, which is the total current. What we want though is the current going through RL, and that is 0.4 amps going up, if you will, through that resistor. So we're going to move on and basically do the same thing again, looking at it from the perspective of the other voltage source. So we're going to short VS1 and then take a look at the current going through the load resistor. So if we take a look at the circuit that we have then and draw this out. So we have VS2, and then we've got our resistors in here. And so our circuit looks like this. Notice we've shorted out VS1. Now we're going to look at it from terms of VS2. We'll put our resistor values back in here. And then we'll take a look at how much this adds up to, or what we get for a current. So take a look at the circuit then from the perspective of the 14 volt source. So we want to find the current that's running in this circuit. So in order to do that, we need to find the total current, and then we'll find the current that goes through the load resistor. So we need the total current. In order to get the total current, we need to know the total resistance in this circuit. So let's take a look at that. So total resistance, and we can call this total resistance 2 compared to the other one. What it's going to be is 15 ohms in parallel with 30 ohms, and then all of it goes through that 60 ohm resistor. So total resistance looks like this. 15 in parallel with 30, if you do the math, that comes out to an even 10 ohms. All of it goes through the 60 ohms, so we get a total resistance in this circuit of 70 ohms. The total current then is equal to, well, the source voltage is 14 volts. So it's going to be 14 volts over the total resistance. And that comes out to 0.2 amps. Now that's the total current. Next thing is we want the current through the load. So we're going to have to use the current divider formula. And be careful, We're taking the total current, but the resistance is really just the resistance in that parallel portion. So be careful with this current divider formula. We have 15 in parallel with 30, and we're trying to figure out the split. How much current will go through that 15 ohm resistor? So on top here, that is the total parallel resistance. And we want to figure out how much goes through the load. So this is 0.2 amps is the total current in the circuit. And the parallel portion had a resistance of 10 ohms. We got that from there. So that's going to go on top there. And divide that by the load resistor. We want to find out how much goes through that resistor. Do the math, and that comes out to 0.133 repeating amps. So there, we just figured out the current going through the load resistor using the source on the right-hand side. Step number 3, what we're going to do is we're going to look at each individual current supplied by VS1 and VS2. If you noticed, the two currents are going in the same direction. And that's important. If they're going in the same direction, they will sum together. So we're going to take the two currents and the direction and basically label them in our diagram just to make sure we fully understand what's happening in the circuit. So if we were to draw this out, is our load resistor. And I forgot to put in the source there. Sorry, that source should be the other way. Let's just try that again. So it looks like this. Now we'll put both sources back in. We'll put in the resistors. And then we're going to go in and just label those currents. From each one. So let me grab a different color here. So coming in from VS1, that's supplying a certain amount of current. That came out to 0.4 amps. So that's the current going through RL supplied by VS1. Now, if we take a look on the other side, the current supplied by VS2 goes around in this direction if we follow conventional current flow. And that came out to 0.133 amps. As we said, they are both going into the resistor in the same direction. That's important. So as they are both going in the same direction, then we will sum them together to get the total current going through RL. So just write these out so we get these steps here. So we're going to add those two together. So once we do that, we see the total load current is 0.533 amps. That's going to be the load current. And the very last step, we want to find the load voltage. So step number 4, we'll do that. Now that we know the current, that's a simple calculation. So just multiply the load current by the load resistor. So that's going to be 0.533 amps multiplied by the load resistor, which is 15 ohms. And that comes out to 8 volts. So using superposition, we figured out the load current and the load voltage. That's it for this video. Try the ones in your book and see me if you have any questions.